Hello everyone, welcome to IIT and Gate classes. I am Vipin Kumar and today this is a demo lecture for thermodynamics subject for Gate 2024. So very soon we are going to start. Let's wait for 30 seconds for other people to join. Okay, so what is the objective? Let us discuss few things here. So this is a demo lecture. So I am hoping that if you are preparing for Gate 2024, we have some basic idea about thermodynamics and the concepts that comes into thermodynamics. Okay, so in this topic today we are going to discuss the difference or the relationship between the first and second law of thermodynamics. What is the relationship between the first and second law? What was the first law? In very brief we are going to discuss, but moreover we are going to focus on what is the limitation of the first law and why the second law was required at all in thermodynamics. Okay, so that is the objective. Because understanding first and second law individually is okay, but to connect first and second law is more important. Okay, so that is what we are going to do in this demo session. Brief introduction about me. So I've done my MTech from IIT Kharagpur. I've done my MSc from Politecnico di Milano, and I have around 5+ years of teaching experience, and most of it is in Gate. Okay, so now before we even start the lecture, let us briefly discuss what is the official Gate syllabus. Okay, so this was the Gate 2023 syllabus. Very soon the Gate 2024 notification will be out, as well as the syllabus will be out, but it can be assumed that the syllabus will not be very different from Gate 2023 syllabus. Okay, so anyway, more or less we are going to start our preparation for Gate 2024 based upon the syllabus of Gate 2023. Okay, so let us discuss. It is the official syllabus. Of course, it is not, the syllabus is not exhaustive. Okay, there are so many small things that are not mentioned in the syllabus which we are going to cover during our classes. Okay, but still let us see what is given in the official syllabus. Okay, so the very first topic is thermodynamic system and processes. Okay, so what are the different types of system? For example, open system, closed system, isolated system. Okay, so if we define systems, we have open, closed, and isolated systems. Okay, then what are the thermodynamic processes? We are going to discuss thermodynamic processes: constant volume, constant pressure, constant temperature or isothermal, adiabatic, polytropic. Okay, then this comes under the basics. When we start thermodynamics, first of all, there is a basic introduction of thermodynamics. We are going to cover this part in that. Then properties of pure substances. Okay, in this we are going to see how a pure substances behaves. We are going to talk about phase diagrams, saturated liquid, saturated vapor, and all these things. Wet region, how to calculate entropy, enthalpy, and all these things. Then behavior of ideal and real gas, how the ideal and real gas behaves. We all know what is ideal gas equation. PV is equals to nRT. Okay, so if there is a hypothetical gas that can behave as ideal gas, it is going to follow this. Okay, PV is equals to nRT or MRT based upon what R you are taking. Now the main part starts with Zeroth law of thermodynamics. It is the basis for temperature measurement. Okay, then we move on to first law of thermodynamics. Very important is this first law of thermodynamics. Okay, it is, I think, the biggest topic as in thermodynamics, and the most important. Most of the questions comes from this topic, first law of thermodynamics. In first law of thermodynamics, we are going to see how do you calculate work and heat in various processes as well as in various systems. For example, we have open system, we have closed system. So how we are going to calculate the heat transfer and work transfer in different processes and different systems. Okay, so this is basically the first law. Okay, of course, so it is going to take around 2 or 3 classes to cover this. Okay, and it is very important. Now next we start with second law of thermodynamics. Again, very important, second law of thermodynamics. And a very important and very confusing topic comes in this, which is called as entropy. Okay, I think 90% of students remain confused in this topic. Okay, so it's very important to understand, summarize, and classify the different processes in entropy and how to do the calculation for entropy in different scenarios. Okay, next is thermodynamic property charts and tables. Then available energy or availability and irreversibility. It's not a very big topic. Okay, so these are some small topics. Okay, thermodynamic relations, availability and irreversibility, and property charts. So to summarize the syllabus, I can say that the most important topics in the whole syllabus of thermodynamics is first law of thermodynamics and second law of thermodynamics. We will see this very soon, that how many questions have been asked every year consistently from these 2 topics. Okay, that is what we are going to see, how many questions actually come from each topic, but we're going to see that every year most of the questions comes from these 2 topics. Okay, and this is why I have chosen this topic, to understand what is the difference, what is the relationship between first and second law. We are going to understand them individually in much detail in regular classes, but just to give you some ideas, just to connect some dots. Okay, what was the limitation of first law, what was the need of second law, and what is second law, we are going to discuss in this demo class today. Okay, now moving on, let us take a look on some numbers. Let us take a look on some numbers, okay, so that you can make a decisive decision key what topic to cover. First of all, what is the motivation of covering thermodynamics? Why should you cover thermodynamics? Now what we are doing today is basic thermodynamics. We are going to start with basic thermodynamics, and then a whole subject or a whole topic comes as applied thermodynamics. Applied thermodynamics. Now you cannot study applied, of course, before basic. So basic must be covered first, and without basic you can never prepare for applied. Okay, so if I talk about the combined weightage, then it goes more than 10 marks in gate, in every year actually, in gate exam. So you see 10% of your total weightage out of 100, 10 marks comes from basic combined weightage, basic and applied thermodynamics. Okay, so applied I have not covered here. When we start our subject in regular classes, I am going to cover how many, because in applied we have, what do we have? We have power plant, other IC engine, and RAC. Okay. So all together, again, it comes to around 5 marks. So basic and applied combined comes to around 10 marks. And to cover applied, you must understand basic thermodynamics. So all the concepts that are applied, that are used in applied thermodynamics, comes from basic thermodynamics. Okay, so you cannot just skip basic thermodynamics and go directly to applied thermodynamics. Anyway, so let us see the weightage of last 7 years in GATE from 2017 to 23. Okay, so you see here in 2017. These are 2 papers. Okay, this is paper 1 and this is paper 2. Okay, so 2 questions came in paper 1 and 1 question came in paper 2 of 1 mark. Okay, and this is 2 marks question, and paper 1 we had 1 question, paper 2 we have 3 questions. Okay, so if we combine them and take the average weightage, it is around 5.5 marks, 5.5. Okay, Now again in 2018, if we see, we have 5 marks. 2019 again 5 marks. 2020 again 5 marks. 21 again 4.5 marks. So you see the average weightage of basic thermodynamics in GATE every year consistently, sorry, is around 5%. Okay, 5 marks out of 100, so 5%. But if you see this 2023, although like just GATE happened like 3-4 days back, so I have collected this data. I'm not sure how correct it is, but it's 99% correct. So GATE 2023, we had a single paper, and 2 questions, 2 1-mark question were there, and 3 2-marks question was there. Okay, so the total weight is 8 marks. You see here the weightage of basic thermodynamics, just basic, not even applied, is 8 marks out of total 100 marks in GATE 2023. So 8% of the total weightage was taken by basic thermodynamics. Okay, now if we take the average weightage, it's around 5.5 marks, let's say. Okay, so 5.5 marks is taken by basic thermodynamics. So this must be your motivation, because 5% of GATE is basically the huge number. Okay, now the second motivation is you cannot even think of studying applied thermodynamics without studying or before studying basic thermodynamics. Okay, so you have to study basic thermodynamics to go to applied thermodynamics, and then the combined weightage is around 10%. Okay, chalo. Now you can ask any questions in the you can just write in the chat, live chat, and I can see what you are asking and I can reply also if you have any questions. Now I was saying that the first and second law is the most important topics in the whole syllabus of basic thermodynamics. So I was not just saying it because I am taking up the topic today. The numbers are saying this. So if you see again, it is last 6 years chapter wise weightage. 2023 I have not collected it yet. Okay, so it is from 2017. This question weightage is 2017 to 2022. Okay, 2023 data I have not collected in this sense. I have only collected in this sense. Okay, how many questions were there? The questions came from what topic? This I have to check again one more time. Chalo. Now if we see from the basics, this we call it as basics of thermodynamics or introduction to thermodynamics. 3 questions came. Okay, in 6 years, only 3 questions came from the first chapter, which is basics, thermodynamic systems and process. Also Zeroth law also comes in this. But what I'm trying to tell you, if I talk about the introduction or the very first chapter of thermodynamics, only 3 questions came in the last 6 years. Okay, now if you talk about the first law of thermodynamics, you see 13 questions, total 13 question came from first law of thermodynamics. And same here for second law of thermodynamics, again 13 question came. So you see how much weightage these 2 topics have in the whole thermodynamic syllabus. Then availability and irreversibility, 2 questions, total 2 questions came. Properties of pure substances, 7 questions came. Now it is a topic, properties of pure substances, that are applied here and there. Okay, so you cannot just say that it came from this chapter, because even some questions from first and second law, it is indirectly related to pure substances. Okay, now thermodynamic relation, 3 questions. So just to prove my point here, that first and second law, these topics are the most important topics in the entire syllabus of basic thermodynamics. Okay, so we need to focus, and these are the lengthiest topic also. It is going to take a lot of time to cover this. In fact, around 60 to 65% of the total time we are going to spend in just these 2 topics, first and second law of thermodynamics. So I think I have given you enough motivation to start, first of all, thermodynamics. and then not just start, because if you are preparing for GATE 2024, of course you have to study, but why you should study, I have given you the motivation. I have also told you what topics are important. Okay, now let us move on to the main topic for today, which is the relationship between, or the difference between, the first and second law of thermodynamics. So there are few people, live here. Can anyone tell me what is the first law of thermodynamics? Anyone? Very quickly. I'm not going to wait, for a longer period. Just tell me if you have any idea what is the first law of thermodynamics. Whatever whatever you understand when we say first law of thermodynamics, just write in the chat box and we will discuss what you are saying. Because if we have to understand the relationship between first and second law, of course we need to understand what is the first law. Okay, and I hope that you are in third or fourth year of your college, or you may have passed your college now. So I'm guessing that you would have some idea on first law of thermodynamics. Anyone? Okay. So when we talk about first law of thermodynamics, it is a natural law, not natural law. Okay, it is a law of nature. Yes, very nice. It's energy conservation, and it is very important, Kanish, that you are saying energy conservation. Okay, because this is all first law is. This is what first law is all about. And when I say in the same terminology, if I ask you what is second law, then you should say energy conversion. Okay, so this is the main difference. This is the main difference between first and second law. That first law is all about energy conservation, and second law is all about energy conversion. Okay, so what is first law? First law is the law of nature. We all have heard that energy is conserved in the universe. Energy cannot be created. It can only be converted from one form to another. Okay, you cannot create energy. Either you are giving energy, you are whatever energy you are getting from the system, either you give it or it is generated in some way. Okay, with some fuel, some chemical energy is converted into mechanical energy, some heat is converted into work, kinetic energy is converted into work, or some other way. But energy must be converted from one form to another. There is no infinite source of energy. You cannot just create energy from somewhere. Okay, so to define, first law is the law of conservation of energy. Very basic definition. Okay, it states that energy will be conserved when a system undergoes a change of state or a thermodynamic process. Whenever a process is happening, okay, whenever a process is happening, and even if you want, you can take a very natural process like moving on a upward slope, or going on a downward slope, or moving just on a plane surface, just walking. So these are all processes, and some type of energy is getting converted into some other form. For example, your chemical energy, if you are just walking, chemical energy of food is converted into your physical energy, okay, which is also mechanical energy, okay, because you are moving. Okay, so it states that energy will be conserved when a system undergoes a change of state or thermodynamic process. It cannot happen that you do not eat food for 10 days and you can just walk, because you need energy. That energy that you is required while walking must become, it should come from somewhere. Okay, you cannot your body cannot just generate energy. Okay, so whenever a process happens, energy must be conserved, and energy can only be converted from one form to another. So if you have a system, what can I say? If some energy, for example, this system is there, energy is going in and some energy is going out, and let us say some energy is generated as well inside. How it will be generated? Some fuel is there, it is burning. Okay, fuel, when you burn, it will release some energy. Okay, or a nuclear rod is there, which is going to generate some energy. Okay, so I can say energy in, you are transferring energy from outside, plus energy generated is equals to energy out plus energy of the system, change in energy of the system. Okay, and you cannot violate this law. This summation will be equal to this. It can never be greater or less than, I mean, the left hand side will always be equal to right hand side. It can never be greater or less than that. Okay. Now in thermodynamics, we assume that there is no chemical reaction. Okay. No chemical reaction, no mass transfer, and therefore energy can not be generated. I am saying only in thermodynamics we are assuming that energy generation will be zero. And that is why in thermodynamics we use this relationship. Okay. Now, if you have a system and system has some mass, for example, it has some water, some air. So whatever it is, it will have some mass, it will have some molecule. And whenever a system has some mass, it is going to store some energy. A system can store energy, or a mass can store energy only in the form of internal energy, kinetic energy, and potential energy. In these three forms, energy can be stored. Any mass can store energy in these three forms. Okay. Now again in thermodynamics, we assume that the, just 1 second. Okay. So I hope what I'm writing is visible to everyone. Can you confirm if it is visible? Okay. So it's very important that you understand that it is specifically defined for a process. It is specifically defined for a process. And whenever thermodynamic process is happening, you can apply this equation. So many times during our regular classes, when we cover first law, we are going to use this equation so many times. In fact, in each and every question, we are going to use this equation. Okay. Now, the same can be used for a first law of thermodynamics for a cycle. Now, some process is happening, and like there are 3 or 4 processes are happening in such a way that a cycle is being conducted. A thermodynamic cycle is being conducted. Okay. Now, I hope that you have little bit of idea, which we are going to again cover in detail, that for a cycle, change in property will be equal to 0. Now here the term that we are using, internal energy, this is U is internal energy, and it is a property of the system. It is the property of the system. So as we know, for a cycle, change in property will be equal to 0. And I have just told you that U is a property. It is internal energy is a property. Now change in internal energy for a cycle will be equal to what? Will be equal to 0. So if I again use my same equation, energy conservation, dq is equals to du plus dw. And if I apply this for a cycle, if I apply this, when I apply this for a cycle, I can write du is equals to 0. Okay. So what do we have now? dq is equals to dw. So again, very important to understand that this is the first law of thermodynamics for a cycle. Okay. So I hope that you are able to distinguish between first law. First of all, what is first law? It is an energy conservation law. Second, what is the first law for a process? And then what is the first law for a cycle? Okay. So I hope this you are able to understand till now. Okay. So I hope that you can answer this. I have few people in the chat. Can you tell me what is the right answer? First law of thermodynamics deals with. Can anyone tell me which one is the right answer? A, B, C, D. Conversion of heat into work. Conversion of heat. Conservation of energy. Conservation of entropy. Can anyone very quickly tell me what is the right answer? Quickly. First law of thermodynamics deals with. That is correct. That is correct. Conservation of energy. Connection. That is absolutely correct. Okay. Now, a little bit, I hope that you people have little bit of idea about PMM1. So if you will answer this, I will move on, and again, of course, we are going to cover this in a regular class. If you don't answer this, then I will explain what is PMM1. But can anyone tell me PMM1? What is PMM? Perpetual motion machine. Perpetual motion machine. So PMM1 violates which law of thermodynamics? First law, second law, third law, or it doesn't violate any of the laws? It is possible. Can you tell me which is the PMM1? PMM1, perpetual motion machine 1, violates which law of thermodynamics? Is it the first law? Is it the second law? Is it the third law of thermodynamics, or none of the above? So just very quickly, let me tell you. PMM1 is basically, it is a thermodynamic device that works on a it is a device that basically works on a cycle and gives you continuous work output. So we have a device which is giving you continuously work output without exchanging any energy. So here we are not giving any energy. We are not giving any energy, but it is giving you work output. So basically this device, what can I say? This device is creating or producing its own energy. So is it possible? Is it possible? Is a device that is any device that is creating its own energy? Is it possible? Anyone? Here I am not giving any energy, but it is giving you some work output. So basically I am not giving any energy, but it is giving you some form of energy. Is it possible? Anyone? Very quickly tell me, is it possible that a device is creating its own energy without exchanging any energy from outside the system? No, that is not possible. That is not possible. Okay. There is no device that can do that. And if there is a device that can do it, then it is violating the law of nature. It is violating the first law of thermodynamics. So basically, PMM1, yes, first law, very nice, Aman. So PMM1 is violating the first law of thermodynamics, because first law is telling me that there is no device that can create, there is no system that can create its own energy. No, there is no system in the universe that can create its own energy. The energy will be converted from one form to another. Okay, only conversion of energy from one form to other can happen. Energy cannot be created or destroyed. Okay, so if I am telling you that I have a device that is giving me continuous energy output, but I am not giving any energy to that system, to that device, that means that device is violating the first law of thermodynamics, and it is a hypothetical device. It's not possible, of course. So PMM1 is impossible because it violates first law of thermodynamics, and there is no system in the universe that can violate first law of thermodynamics. It's not possible. It is going, if a system is doing it, that means it is going against the nature. It is violating the natural laws. Okay, chalo. So I hope that you, of course, it is not an exhaustive, explanation of first law, because first law in itself, it is going to take 1 or 2, around 4 to 5 hours, maybe more than that. So, but I have given you a little bit of idea what first law means. Okay. Now the point is that what is the limitation of first law? What is the limitation of first law? So there are three limitations. First is direction of the process. Second is feasibility of the process. And the third is quality of the process. Very quickly, we are going to understand what each and every word means here. Okay, very quickly. So when I talk about the direction of the process, now let us talk about first direction of the process. What do you mean by direction? Direction of a process. It means, you tell me one thing. Look, we have a hot body here. We have a hot body which is at temperature, let us say T1, and we have a cold body here. Which is at temperature T2, and if I am saying hot body means T1 is greater than T2. Now, if these two bodies are coming in contact with each other, how will the heat transfer take place? How will the heat transfer take place? 1 second. Okay. So when I say direction of the process, it means that the process goes in a particular direction. For example, the heat transfer happens always from a high temperature to low temperature. Heat transfer naturally, I am saying again, naturally. It can never happen from a cold body to a hot body. If you bring together a hot body and cold body, it can never happen naturally that the hot body will get much hotter, much hot or much hotter, and the cold body will get colder. Okay, it can never happen again naturally. Okay, spontaneously it is not going to happen. There are processes that it can happen, but naturally it will never happen. Okay, is it correct or not? Is it correct or not? Yes, hot to cold, it will happen. So if the heat transfer is happening from cold to hot, it can never happen naturally. I need to install some system. I need to give some extra energy from outside the system, then only it can happen. But again, spontaneously, it can never happen. So the direction of heat transfer will always be from a high temperature to low temperature. Okay, so I can say heat transfer will always happen from high temperature to low temperature. Now, high temperature to low temperature is happening naturally. But you see, naturally, low temperature to high temperature will never happen. It will never happen naturally. Never happen naturally. Now, first law doesn't tell me about this. First law says if there is a temperature difference, heat transfer will happen. Now it will happen from high to low temperature or low to high temperature. First law is not telling me. First law is only telling me if you have if you have two bodies and they have a temperature difference, then there will be a heat transfer, and during that heat transfer, energy will remain conserved. That is the only thing that it is telling me. Now, it is the second law that is telling me that heat transfer will always happen from high to low temperature. Okay, so again, to summarize, when I talk about direction of the process, first law gives me no idea about the direction of the process. It only tells you that if the process is going to happen, the energy will remain conserved. If it is going to happen in that direction or not, it will not tell me. It is the second law that is going to tell me that if it is going to happen in that direction or not. Okay, so first thing is direction. Okay, is it clear? Then the second is feasibility. Okay, what do you mean by feasibility? By if I talk about feasibility, let me add a page here. Okay, so when I talk about feasibility, B part is feasibility. What do you mean by feasibility? That if feasibility means possibility of the process, even if the process is going to ever happen or not, possibility of the process. If the process is even possible or not, this is the feasibility. Now let us say you have a electrical circuit. There is a voltage difference and some current is going through it. It is a resistor. It is a resistor. Okay, resistance. Now when the current will pass through this resistor, the heat will be generated. So what is happening here? Electrical energy is converted to heat energy, right? And when this is happening, first law tells me that energy will remain conserved. Energy will be conserved. Okay. Now, according to first law, it is also possible. It is also, I mean, it is according to first law. What we can do is, if again I have a system here, okay. Now tell me one thing. 1 second. Okay. So I have made an electrical circuit again. Okay. Now tell me, if I give some heat to this system, if I give heat to this resistor, is it possible that it is going to create a current and finally a voltage difference will be created? Is it possible? If I pass some current in this, then eventually it will create a voltage difference. Is it possible? Is it possible or not? Here, what is happening? Electrical energy is converted to heat energy. Here, heat energy, I want to convert. I'm not saying it is converted. Heat energy can, let me write it a question. Can heat energy be converted to electrical energy? No, we cannot do that. We cannot do that. You see, first law is only telling me when this process is happening, energy is conserved. First law is giving no restriction. It is telling me if you can do this, if you transfer heat and somehow you create some current and a voltage different, still energy will be conserved. But it is not telling me if even this process is possible or not. There is no indication by the first law about the possibility of the process. First law is telling me you do it. If you do it, if you be able to do it, the energy will be conserved. It is just telling me energy is conserved. That's all. If you are able to do it or not, first law is giving me no idea. So again, it is not giving me any feasibility of the process. Feasibility of the process. Okay. Now there is one more reason that heat energy cannot be converted into electrical energy also, because of the quality of energy. Heat is a low grade energy, electrical energy is a high grade energy. So the last difference that comes here is quality of the process, quality of the process or energy. Okay, are you able to understand what we are discussing? Is any doubt till now, anyone? Then we will move on further. Quickly tell me if any doubt till now here, yes or no. Anyone, any doubt? So should we move on? Chalo. So the last is quality of energy. Now what do you mean by quality of energy? Look, when we talk about first law, so first law is a qualitative law. First law is a, I'm sorry, quantitative law. Quantitative law. What do you mean by quantitative law? It talks about the quantity of energy. Okay. For example, if this amount of energy, for example, 50 units of some energy is converted into some 20 units and 30 units are gone somewhere else. Okay, very nice. Just 1 second. Okay, so am I audible? I think just 1 second.
You are currently the only person in this conference.
to stream. Three dots means you have to, I think, you are not able to join.